Downer is very proud to bring this podcast series to you. At Downer, our purpose is to provide the vital services that connect communities and enable them to thrive. We do this by assembling the best minds, harnessing the power of technology and our enduring relationships to deliver sustainable outcomes for all.
My name is Jo Taranto and I'm joined today by Rob Martinovic, the Technical Director for Gasification at Downer. And we're talking biosolids gasification. Thanks for joining me, Rob.
Thanks for having me.
Tell me, what is biosolids gasification?
Okay, so for those that aren't familiar with biosolids, it is a byproduct of wastewater treatment. Pretty much every wastewater treatment plant in Australia generates this stuff. For a long, long time, the industry as a whole used to just send it to farmers to compost onto the land because of some of the kind of inherent characteristics of it, primarily around things like carbon and phosphorus. And it's kind of worked for farmers, but in recent years, there's been a increasing awareness of what's in it beyond just carbon and phosphorus. And not to mention that water authorities have to pay to get rid of this stuff. Now you can imagine that across the industry, we're producing a lot of it. We're talking about, hundreds of thousands of tons every year. It's a substantial issue for the industry in terms of, a cost. Unlike other utilities, the water industry has been really reluctant to raise water rates. So the cost burden is on the utilities. And so there's been a big push to look at how do we mitigate some of those costs. And then, as I said, there's been increasing awareness of, things like PFAS. PFAS is a pretty hot button topic in the community at the moment. Unfortunately for the water industry, it generally doesn't make PFAS, it doesn't create it. But because of the nature of what's in the environment and things like, water running into sewers and, other catchments, PFAS becomes the wastewater plant's issue because it concentrates it. So what the industry and regulators, so things like the EPAs and the EPA equivalents across Australia, plus the Commonwealth Department of Environment, what they've been looking at is how do we remove this if possible. So there's been a lot of work done that Downer and some of its partners have done over several years to look at primarily those two issues. How do we mitigate operating costs and how do we also then destroy contaminants? And it's led us to what was built at Loganholme. So it's the first of its type on a municipal scale. Downer had in the past run some trials. They were highly successful. There is a lot of research by others as well in this field. We're not the only ones. It's just that we are the first who have been able to demonstrate it at a scale that can be built and is now operating and is fully functional.
And so it involves a process called gasification. What does that do to biosolids?
Are you familiar with how they make charcoal?
No.
Okay. So charcoal is wood that is essentially cooked in the presence of very little oxygen, because if you have a lot of oxygen, it burns and turns to ash, so that's combustion. But if you have an environment where heat is applied and very little oxygen is present, what it does, it actually then just carbonizes it. And essentially that's what gasification does. So we're taking the biosolids, which look like wet mud, essentially. And through a number of sort of steps, we end up with a very hard pellet, if you want to call it, like a granule called biochar. And it's essentially thermally treated. So there's a couple of stages in that. The first is that we dry it. So we take that wet mud and we dry it to about 90% total solids. That then gets fed into that kind of oven, essentially, which we call a hearth. It lives in there for about 100 seconds. That operates at around 650 degrees. There is a little bit of oxygen there. The bottom end of that process produces a biochar, which is a beneficial product. Like, it can be sold. It has properties that are beneficial to the environment. All the contaminants that you previously had, so I mentioned things like PFAS, there's also things like hydrocarbons, microplastics, all of those things, they all become gaseous at 650 degrees. So what we then do is, the second stage of this process is we take that hot gas and we introduce a little bit more oxygen, so it becomes hotter. It goes up to about the kind of 850, 900 degree mark, and we combust it. All of those contaminants in that second stage are destroyed. We then recover that heat, because that heat is recovered to dry the material as it comes in. So it's a kind of a circular process. So the gasification process is the back end of it, but it's critical to the front end.
And it's really creating some very beneficial outputs, I guess, which must be pretty exciting.
Well, it is. It is. I mean, earlier we were talking about that it's a huge cost impact, for water authorities right across Australia. So now we've turned the thing where they, depending on where you are in Australia, people are paying anywhere between about $100 and $300 a tonne to remove this. All of a sudden, you've gone from that to being a saleable product. So you can imagine the cost savings that water authorities are going to be able to realise. And it's a really kind of hot button topic for some of those authorities in places that have growing catchments. So Southeast Queensland, the outer suburbs of Melbourne, those are really rapidly growing areas. Water authorities are struggling to put enough services in, for those. Meanwhile, they're still needing to replace the older assets. So they're all looking to say, can we find money from somewhere else? This is a pathway to that. I did mention also PFAS. We are achieving, and we've got demonstrated results that show a greater than 99% destruction rate of PFAS, which is keeping the regulators very happy.
You're listening to the Australian Water Association podcast series, and I'm speaking with Rob Martinovic from Downer. Tell us about the Logan Home wastewater treatment plant. Is this an Australian first?
Well, the treatment plant, it's not. It's an existing treatment plant. What we've done is built a gasification plant it's co-located on the site. So the treatment process is existing. There is another project underway to increase its capacity, because this Logan area is one of those places in Australia that has substantial population growth. So there's been a lot of investment into increasing its treatment capacity. There was some spare land there, so the Logan Home gasification plant was built, and it takes all of the waste-activated sludge from this plant and turns it into biochar. So in that case, you could consider it an Australian first. Like I said, there are other trials. Like we actually ran a trial at Logan Home in 2020, but it wasn't a self-sufficient trial. It was a limited run. So from a perspective of, is this a process or a plant that sits there and is, it can be run automatically and it can be run 24 hours a day? The answer is yes.
Has it got the eyes and ears of the industry, do you think?
It does. It does. And it's captured the interest in a number of different ways. So as I said, the cost driver is a big thing for some authorities. There are others out there who are a little bit more, maybe, I'm not going to say proactive, but they're probably thinking about potentially future-proofing their business. There is some looming legislative changes. So there's a thing called the PFAS NEMP. The currently legislated version is number 2. There is a number 3 coming out. It's been circulated, but it just hasn't been legislated. That's going to, when it does, is going to make the current practice of land disposal of biosolids, which is the current kind of business as usual process, it's going to make it potentially very expensive for some authorities that have an exposure to PFAS. Now, not every authority does. If you don't have an industrial or largely industrial kind of catchment, you probably may not have an issue. But a lot of the larger authorities in places like Sydney, Melbourne and Brisbane, they absolutely do. So they are, very much trying to future-proof their business.
So what do you think the opportunities are for other utilities?
Well, everyone has to pay a lot of money to get rid of it, so that's an issue. And I know that you talk to any operations manager or a plant manager, that's their number one issue. For most treatment plants, biosolids treatment and disposal is either their number one or number two single largest OPEX. They would love to remove at least some of that. The other issue is that, from a community aspect, quite often these biosolids are transported long distances. So for example, in Sydney Water take all of their biosolids and it goes all the way over the Blue Mountains and is disposed on land on the other side of that. In Perth, for example, the Water Corporation send all of Perth's all the way out to the Goldfields and Agricultural region. So there's significant transport related to that. A lot of people who live along those transport routes don't really like all those trucks. There's also the other aspect which we haven't spoken about, in that a lot of businesses or a lot of these water authorities have stated claims about being carbon neutral by a certain date. 2030 is pretty common. It's a challenge for them to try to meet those carbon neutral targets when they start to factor in transport related emissions that they're directly responsible for. So one of the benefits of this is that from the time that you take the biosolids out of your process to the time that you create biochar from it, there's approximately 90% reduction in volume. So even if you didn't have a buyer and you were actually still disposing this on land, your truck movements have been reduced by 90%. So you've got a 90% reduction in your disposal costs and also the related carbon emissions that go with that.
Is there more research and work that needs to be done, Rob?
There is. One of the I suppose challenges that we've got is the biochar market itself is very kind of in its infancy in Australia. There are biochars out there that have been there for a while that are made from, I suppose, natural biomass, so things like tree, like let's say tree waste or agricultural waste. There's not really any contaminants involved with those, so that's quite kind of well understood. The biochar market from biosolids is new. We've spoken about Loganholme. It's pretty much the only site that generates it on any substantial volume. There are things like heavy metals that are in the biochar. So the challenge for us is to look at how do the regulations govern that? Because, for example, if you put biosolids on land, all of that breaks down when it becomes biodegraded, and those heavy metals can leach into the soil. Biochar doesn't have that same property. So one of the things that we're speaking to regulators about is to look at whether the heavy metal concentration, do we look at it on a kind of a gross concentration, or do we look at what the available concentration is? But there's a lot of research going in on that shows like next to no leachability on that.
It sounds like it's just the start. Are you excited by the opportunities?
I am. Yeah, I'm kind of fortunate. If I go to a barbecue where I don't know people and they typically say, "Oh, so what do you do for work?" And if I kind of explain it in pretty broad terms, people are usually pretty excited by being able to actually do something to help the environment, because it's a pretty a key or a common theme, sustainability. So I feel fortunate, and the team that I'm a part of, it's not just me solving the world. There's a whole bunch of us, but we feel all very fortunate that we're in a position where a real benefit to the Australian environment can be achieved.
I've been speaking with Rob Martinovic, the Technical Director for Gasification at Downer. Thanks so much for sharing this with us today.
Anytime. Thank you.